Yeah, so basically this is our mini setup. The LEDs are here, and the longer one is the positive terminal, the shorter one is the negative terminal. Yes. Then we have a breadboard here, and then we also have a Raspberry Pi. Yeah, I'm running I'm running the desktop remotely using real VNC, like you see. The real VNC. Yeah, I installed it on a Ubuntu machine. Yeah, so yeah, and this is my power source. Yeah, I'm just using a regular power bank. Yeah. So like I said, we are going to first test with one LED to see how the connections go. Yeah, so I'll put the longer LED terminal in one slot, and then the other one on the other slot, just like you see there. Yeah. Yes. Yeah. Yeah, so I'm going to follow this chart. First, I'm going to try to test to see that that this actually works. Yeah, I'm just going to connect the LED to the 3 volts temporarily to see that it works, and then I'll disconnect. Yeah, if you have some resistors, you could use them, but right now I have no resistors, so I'm just going to connect directly. Yeah, so I've connected the positive to the 3 volts. Like you see, the 3 volts is the first pin here. Yeah, on the GPIO. Yes. So I've connected it there. Then ground is the third pin. Is the third pin there, just like you see. Yeah, it is labeled ground. It's labeled ground. Yeah. So I'm gonna get one connection here. I plug it in there. Yeah, and then I'll connect it to the negative side. Yeah, if it doesn't briefly, actually I connected it to the wrong terminal. Yeah, that's why it is always good to instead use if you can, you could instead use a bus. A bus could help you actually label the pins better, because it comes already labeled with everything. Yeah, but so finally this shows that our LED is working. Yeah, then you can just disconnect. Yeah. So in order to program it, we are going to connect it directly to GPIO 14 here. GPIO 14. Yes, we're going to connect it to GPIO 14 so that we are able to control it programmatically using Scratch. Yeah, so I'm going to reconnect the ground, and then I'm going to disconnect from the 3 volts and connect it to the GPIO 14, because basing on the diagram, actually GPIO 14 is just close to the ground, just like you see here. This is the ground, and this is the GPIO 14. Yes. Yeah, so that was our first part of setting up our simple circuit. Maybe just to give you a small heads up, you see I've managed to connect this to the positive LED because there is continuity here. There is continuity here in these rows. Yeah, even if I skip, there is nothing. And then here there is no connectivity, and then it's the same side here. There is continuity on this side. That's why you see that I've managed to connect these two, even with these spaces. Yes. Yeah, maybe in the later future I'll I'll do a tutorial for how the breadboard works. Yes, so we are going to start off with programming one LED. Yeah, the green LED I showed in the illustration. Yeah, so that then afterwards we will go ahead and maybe create a future. We'll create a more bigger project maybe of the traffic lights. Yes, so I've started off by opening Scratch 3. It will take some time on the Raspberry Pi, since yeah, I'm using the Raspberry Pi 3 and the processing speed is not that great. I believe also it has 1 GB of RAM, so we just have to give it some time. Yeah, but if you have better Raspberry Pi versions like Raspberry Pi 4 or a Pi 5, this could be even faster. Yeah, but let's give it some time. Yeah, it's taken around 2 minutes. Yeah, but like I said, on other Pis it could even take a shorter time. Yeah, so before we start, we shall just go here to the add extension and import the Raspberry Pi GPIO extension. Yeah, so once we get in here, yeah, so basically it's gonna be a small project. I'm just going to have the green flag here. So when green flag is clicked, I'm just going to get a loop here, a loop. Okay, yeah, that is going to repeat 10 times. Yeah, that is going to repeat 10 times, and then so basically once it is repeating 10 times, I just want it to set GPIO. Our GPIO pin is 14. Yeah, is 14, just to confirm. Yeah. Yeah, so we're going to set it to high, and then we'll wait for 1 second. Yeah, so in the control here, and then again we set it low. We set it low. Yeah, we set it low, and just to be sure that actually our GPIO pin has been low from the start, we can add an extra block here when the green flag is clicked. So in the beginning, even when the green flag is clicked, we want it to have this GPIO pin at low, just in case anything else might have happened. Yeah. So yeah, I've done the first test and all seems well. Yeah, but from the look of things, I think I may need to add another wait block after here to kind of like see that start stop, because right now I'm only seeing the LED stop at once. Maybe let me start the recording. Just in case. So I've clicked the green flag here, and you see there is no blinking, and yet the intended outcome I wanted was the blinking. Yeah, so I'm just going to add another wait block. Yes, like I said, I've added another wait block there for 1 second to at least ensure that we get the blinking we want to see. Yeah, exactly. And now we have finally gotten the blinking we want to see, because yeah, that means we added that wait block when the pin is low. Yeah, so that it can give us the chance of actually seeing of seeing that instance when the pin is low. Yeah, just one final time. Yeah, so basically, and these are the same concepts we shall use in our traffic lights project, whereby we'll be able to add more than one pin. Yeah, but basically this is how a Raspberry Pi controls how you can control physical devices, or you could call it physical computing, on a Raspberry Pi using Scratch. Yeah, thank you very much, and see you in the next tutorial.